Okay, let's talk about organic reactions. Are you ready? I use this acronym to remember. There are 7 organic reactions to remember. PS phases: polymerization, saponification, fermentation, addition, combustion, esterification, substitution. Now there are 2 S's, so does it matter really where you put the first S or the second one? Not really, but it's an easy way to help you remember the 7 organic reactions. So P, polymerization. What is a polymer? A polymer is a big, giant, huge chain made up of monomers. So what's a monomer? Well, it's a little molecule. So you take a little molecule and attach it to another little molecule and then do that hundreds or thousands of times, and then you get a polymer. So polymerization is a reaction that joins many monomers to produce a polymer. Here's an example of what it would look like. Monomer, 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 join them together, polymer. This right here, this N represents like a big number, 100, 1,000, something like that. And then the same number would be right here, meaning now they're attached in a chain. So I had like 1,000 of them individual. Now there's 1,000 of them connected. I had 653 individual. Now there's 653 connected in a chain. So we use the products from polymerization a lot. So you can see just as a few examples, polyethylene is a polymer and it's used in plastic bags, bottles, toys. We have polypropylene that's used in carpeting and bottles and luggage. We have polystyrene, so that's what we would call styrofoam, like takeout trays and packing peanuts. Those are just a few examples. So polymers are very common in our everyday life. Okay, next up is saponification. Saponification. Saponification is making soap. And look at this. So do you see the beginning of this? Soap, saponification. Same letters, so just scrambled up. So saponification means making soap. So we use a fat and we use a strong base, and then we're going to get soap. So for example, here's a reaction. It's a fat. It's going to be like a big molecule. And here's how you're going to be able to identify saponification. Easy peasy. Look for a base. Remember, we're going to look for an OH. We can find bases in the reference table, right? But we're going to look for OH, and that is indication. Ding, 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 ding. We got a bunch of big molecules hanging around here, a lot of carbons. It's an organic reaction. This is going to be saponification. Next, we have fermentation. Fermentation is usually taking a sugar, in this case it's glucose, and usually we're going to add yeast, and we're going to get alcohol and carbon dioxide. So when you look at the product side, you're going to look for carbon dioxide, okay, but then you're going to look for an alcohol. Now, they might not tell you it's an alcohol, but you're going to have to be able to notice it from the chemical formula, or just that it ends in OL, anol, and alcohol, okay? So you're going to see on the product side an alcohol and carbon dioxide. Now we're on to addition. So in addition, we break a double bond, and then we have space to add 2 atoms. Okay? So typically it's with a double bond. Could you do it with a triple bond? Yes, but most of the time you're going to see it with a double bond. So because that double bond is there, those carbons have one less atom stuck to each of them. So when I break that double bond, now there's space to add something in its place. Usually we're going to add hydrogen or a halogen, something from group 17. So let's look. So here we have a double bond. What are we going to do? Break the double bond and then put what we had here in its place. Add them in. So here we have a double bond. We're going to break the double bond. What we have available is bromine, and then we're going to stick the bromines in the available locations. addition. Combustion we covered before. Combustion is when an organic compound, so a carbon-hydrogen-based compound, burns in oxygen. So you see I need oxygen as a reactant to produce carbon dioxide, water, plus a lot of heat and light. So carbon dioxide is a product, but I have to be careful, right? Because carbon dioxide was also a product in fermentation, but this one has carbon dioxide with water, and fermentation would have carbon dioxide with alcohol, okay? So here's an example of what it would look like. We have an organic compound, a carbon-hydrogen-based compound in the presence of oxygen and producing carbon dioxide and water. Esterification, not shocking, is producing an ester. It uses an alcohol and an organic acid to do it, but that's not the important part. The important part is it makes an ester. How will you know it made an ester? You have to look for the functional group of an ester, or that this is the name of an ester. Okay, that's it. Esterification, making an ester. And then finally, substitution. Just like in a game, substitution is when you take out one and replace it with another. So usually it's just one single atom that's replaced. So usually we took off a hydrogen, and often we just put a halogen in. So we remove a hydrogen, put in a halogen. So you can see right here, we remove a hydrogen, put in a halogen. You can see right here, we remove a hydrogen, put in a halogen. You can see right here, remove a hydrogen, put in a halogen. Substitution. So again, PS phases: polymerization, saponification, fermentation, addition, combustion, esterification, substitution. If you put the S's in different orders, it doesn't really matter. Just remember, 7 organic reactions, PS phases. And there you have it. That's organic reactions. I hope you learned something new today.